All right, in the next couple lessons, we're going to be learning how to find missing sides and angles of right triangles using trigonometry. So the first thing we need to be able to figure out how to do is set up a trig ratio to be able to start learning that. So let's remember that when we have a right triangle, the hypotenuse is always the longest side of the right triangle, and it is always opposite of the right angle. Okay? So how do we label for trigonometry? There's these special relationships that exist between in these right triangles, and these trig functions that we're going to use help us with those certain relationships. So first we need to be able to label our triangle. So when we talk about trig, we introduce an angle name called theta. It's just a Greek letter theta, and that is kind of the convention used for naming angles when you're dealing with trig. So sometimes it can be theta or any other named angle that you have. And so there's our angle. And when you label, you think in perspective of, think about if I was standing at that angle. And so if I'm standing at the angle theta, and I'm looking, well, the hypotenuse, we're going to know, is always across from the right angle. So that's always there. And then the opposite to this angle is going to be from that angle across the triangle to the other side. So hypotenuse, the other side of the right angle, opposite from the angle that I'm looking for, across, and then adjacent is the one that is sitting right next to, you can touch it, right next to the angle in question. So I'm looking from the perspective of this angle, this side is opposite of it, this side is adjacent. So I want to be able to label all three sides of my triangle. All right, let's try this one. This is my angle theta that I'm looking at. I'm going to switch my pen color. This is angle theta, and so across from it would be opposite. Across from the right angle is hypotenuse, and next to me, I can touch it, is adjacent. Okay, so once we've learned how to do that, we've got, oh, sorry, here's some more examples. Across, opposite, across from the hypotenuse, from the right angle is the hypotenuse, and then touching is the adjacent. And let's look at one more. Okay, hypotenuse is across, adjacent, opposite is across, and adjacent is touching. All right, so when we're in trigonometry, we're going to be looking for sides and angles. And these trig function relationships have certain names. One is called the sine function. Now we say sine, this is what we say, and this is what we write. So we're not going to pronounce it sin, we're going to say sine, and we're going to write sin. Then there's the cosine function. We're going to say cosine, but we're going to write cos. We're not going to pronounce it cos. We're going to say cosine, and we're going to write cos. And the last one is the tangent function. We're going to say tangent, and we're going to write tan. And we're not going to say tan. Okay, sine, cosine, tangent, but we write sin, cos, and tan as an abbreviation. All right, so what does this all mean? So we've got these certain trig functions that have special relationships, and we have a memory trick. So the sine function is equal to the opposite side over the hypotenuse. The cosine function is equal to the adjacent side over the hypotenuse. And the tangent function is equal to the opposite side over the adjacent side. and this is something you're going to need to memorize. So we have a memory trick. I think it kind of sounds like an Indian Pocahontas kind of a name. We say Sokotoa, Sokotoa. Say it over and over again. Sokotoa, Sokotoa. Sokotoa sine is opposite over hypotenuse. So this is your trig function, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sokotoa. All right, so plan on getting that memorized. So using our sine function, sine is always going to be the opposite over the hypotenuse. So let's see just do an example of that. So here looking at this triangle, so you should have turned your page over to the back side. We have theta. This is the angle that we're looking for. We're going to label. So we're going to say this one over here is opposite. This is the right angle, so this is the hypotenuse. This one is adjacent. It's touching the angle, so it is the adjacent side. And so what we know is that the sine function, so remember, so ka toa, sine is opposite over adjacent. So we're going to write the sine of theta equals opposite over hypotenuse. And that's all we're doing for now. We're not going to actually calculate it yet. We'll do that in the next video. But right now we're just writing the correct ratio. All right. So for this one, from the viewpoint of this angle, this is the opposite side. This is the adjacent side. This is the hypotenuse. So the sine function says sine of 57 equals opposite over hypotenuse. For this one, 32, this is the opposite side. This is the hypotenuse. This is the adjacent side. The sine 32 is opposite b over hypotenuse 100. Okay, let's look at cosine. So cosine is always the adjacent over the hypotenuse. We're going to label the same way, but now we've got, again, what was this? Opposite, hypotenuse, adjacent. So the cosine of this angle theta, cosine is, let's write it out, so ka toa, adjacent over hypotenuse, so that is 8 over 17. Okay, cosine of this angle, so we got a label, opposite, adjacent, hypotenuse. Cosine is adjacent over hypotenuse, so cosine of 57 equals adjacent 5 over hypotenuse C. We're just simply labeling and finding the ratio. Okay, here we go. Try it, see if you can do it. The cosine of 32 degrees. Cosine only uses adjacent and hypotenuse. So adjacent over hypotenuse. All right, now let's set up tangent. Tangent doesn't use the hypotenuse, it's opposite over adjacent. So let's remember, so we're looking at opposite and adjacent. So when we go to label that, we're going to have the angle here. We only care about the opposite and the adjacent. Okay, so tangent of theta is opposite over adjacent. (57°). Again, tangent is opposite over adjacent. Opposite is D, adjacent is 5. The tangent of 57 equals opposite over adjacent. Okay, this one, opposite, adjacent. Tangent of 32 equals opposite over adjacent. All right, and those are the three trig functions. We got sine, cosine, and tangent, and they're different ratios. In the next lesson, we're going to learn how to actually use that to solve, which basically is just going to be a matter of using your calculator. And all right, we'll see you then. Have a good one. Bye.